are going to discuss about the bending stress for unsymmetrical bending of beams. That is coming under for second year students in the aerospace structures class. First, we should have what is symmetrical bending as well as unsymmetrical bending. If you are applying a load on the surface of a beam, if the bending happens parallel to the surface of the beam, that is called a perfect bending. If it is unsymmetrical bending, means you can have the beam as a cross section unsymmetrical beam. Otherwise, even if it is a symmetrical beam, we can apply a load as Q load, means inclined load. That is with respect to the x-axis or y-axis, it may be an inclined load. If you apply like this, the bending will happen unsymmetrically. Let's take easily, we should have an unsymmetrical section. First, let's take our unsymmetrical section, Z section. Let's take the edge section. This is 30 mm and a uniform thickness. Let's take this is 10 mm in uniform thickness, and the fan height this is 70 mm. So like that, then bottom flange be equal to 60 mm. If it is like that, so this is the dimensions of given Z section or unsymmetrical section. How to find the bending stress? So the bending stress can be calculated by using the equation called the sigma, that is mx into ixx minus mx into ixy divided by ixx into iy minus I squared xy into y. That is nothing but m by I into y. So bending stress equal to sigma equal to m by I into y. Where sigma is the bending stress, m is the maximum bending moment, and I is the moment of inertia, and y is the neutral. That is the maximum distance from the neutral axis. Like that we are having. So m by I into y. But here we are going to take along the x-axis as well as y-axis also. Like that we can have. So we just add another y-axis also. So my into iyy minus my into so here mx into ixy divided by ixx into iyy minus I squared xy into x. So like that we can have an equation. Okay. So here the thing is, what is the moment is given? Whether mx is given, we can take. If my is given, we can take as it is. If it is not given, let's take that moment about particular axis is 0. Then we have to find what is the moment of inertia, how to find. Then what about the y value, what is the moment itself. Okay. So first the step is to find the centroid. Step 1 is finding the centroid. The second step is to find the moment of inertia, locate the centroid, locate the CG axis. The third step is find ixx, iyy, ixy. Then find sigma or bending stress at any point, A or B or C, like that. So let's take this is A or B and C or D, E, F. This is G, and then it is given at which point you are going to take bending stress. Everything. But only thing I am telling is that here this y and x, this y and x both are measured from the center axis, from CG axis. Okay, from CG axis only. So after finding or looking the CG value, CG, you find the x value. Because next I am having this point CG, then you just mark this as CG axis. This is right hand side, this is left hand side. So the positive means towards side is positive, towards left is negative for x, and above the value y value positive, below the value is negative. Like that you can have x and y on the CG axis. Like that you can find it. So we all know that how to find x bar and y bar. X bar is equal to sigma a x by sigma a, and y bar equal to sigma a y by sigma a. So according to this, we can find the centroid. After that, how to find the ixx, iyy? This is nothing but icg plus bdq by 12. ICG into a into 1 minute. ICG into a, this x means y square, that is y minus y bar, the whole square. If it is iyy, then same ICG plus a into x minus x bar the whole square. If it is ixy, then ICG plus a into x minus x bar into y minus y bar. Like that we have to approach. Okay. After finding all ixx, ixy, iyy, apply here in this expression, you get the bending stress. One thing is there at which point you are getting. Okay. So if you see means y value is from this point to this point, vertical distance. Okay. As well as x value means from here to here, x value, but it is negative towards left. Thus, it is the central axis. Okay. So accordingly you have to find. You can have a deep session to find or to have solve the problem in the next session. Thank you.